So this is ChatGPT O, and that means not 0 but o1-mini, and it's a bit like a Greased Lightning.
Greased Lightning! Greased Lightning! We'll get some overhead lifter.
As I've said before, it's like Greased Lightning. It's so fast. So just to show how fast it is, I'm going to give it a task to do. Let's just see, it's an experiment, how quickly it can do it. So write the code for a calculator based on Python, because I've got everything set up for Python. It will look a bit like TI-58. I'll just say Texas Instruments TI-58. It will look aesthetically pleasing. Oh, pleasing. And will cater for a wide range of scientific functions like the TI-58. Could do 59. I don't know. Can't remember the difference. Ensure. Oops. Ensure that all error handling is taken care of in the code. I don't know if that's enough, or maybe I should tell it to do more, but I'll just leave it because it's got this reasoning power, and let's just see how good it really is. Oh yeah, maybe, yeah, I said it was aesthetically pleasing. Okay, I'll just write that it will look, the GUI will look aesthetically pleasing. Okay, let's just see what it does with that. Here we go. Now it says thinking, and look at the speed. It's already written the that's the code already. It's probably, obviously it's not done everything, it's only done basic things. Still, it's done sine, cos, tan, whatever. And there's its explanation. It's used tkinter for the GUI. It's created a class called the calculator class. And these are the enhancements it could do. So I suppose without any messing around, let's just copy the code and see if it does what it's supposed to do, and see if there's any errors at least. So I'll go into Python. Calculator o1-mini. So I'm in PyCharm. I'm just going to paste the program in. I've called it calculator 01. It should be 01, doesn't matter. o1-mini. I've pasted it in. Now there will be libraries here, and in PyCharm, it's already got tkinter. It's already got math. So let's just start it and see what it does. My God, it's done it. Whew. First time. 1, 2, 3 plus 4, 5, 6 equals 5, 7, 9. My God. Where's the cancel? It's got that. Pi. All that. It's got to be made a mistake somewhere, surely. Let's say sine of pi equals, it's probably made a mistake there. Yeah. because it's forgotten to close the brackets. I thought it might do that. Let's just do 100 log, same problem. Oh no, of course it would, or maybe it should be log of 100. Yeah, log 100. Yeah, so it's not closing the brackets. It's got E correctly. Oh, that's wrong. Log E, and that should be wrong again because it's not closed the brackets. So equals. Okay, so let's just go back. So that's its first go, which is pretty damn good. And I'll just tell it what it did wrong. When you doing scientific calculations, you are forgetting to close the brackets. For example, you are doing sine of pi with no bracket, no closing bracket. You also need a radian degrees key to switch with a default of degrees. And let's see how quickly it can do this. Fix that problem. It aesthetically doesn't look anything like the TI-58, of course, but it's still quite a nice looking thing. Well, you see it's so quick, it's already done it. Creating, oh, that's the original one, is it? Where's the, thank you. I'll address the issues you mentioned by ensuring that all brackets are properly closed. Bracket handling, degree radians toggle. My God, it's, and then it gives you it's like writes a scientific paper on what it's done almost. It goes into such detail. And look, it tells you all the mode aware trigonometric functions. My God. So it shows you all, so you can read through all that if you like, or you can just cut to the chase and delete the old one and see if it works or not. Let's delete the old one, paste in the new one. Oh, here's the new one. You notice there's no obvious, well, the key's a bit big, never mind. Let's assume that it's got a problem there as well. Let's with the widget, which I can tell it about. Let's do sine of pi. Well, it still hasn't closed the brackets. Oh, it's worked, but it must have been on radians. Let's see. Sine of pi. Yeah, I think it's working in degrees rather. Yeah, that's right. So that's, sorry, not radians. So let's cancel that. So sine of 190 should be 1. Oh, cancel it and put 90 in. 90. I'm trying to use the keyboard. 90, and then sine. No. So sine and then 90. That's it. 89. I'm not sure if that's right. See, let's just see if the square root works. Two. Well, at least that works. The basic calculator works at least. That's a power, I think, that one. I haven't tried that. 2 to the power 4 equals 16. It's got that right. Still not got the trigonometric functions correct. Let's go back. I just give it that information. the trig functions are still not working, and this error appears. Thinking, tracing the issue, revising, evaluating, function handling, ensuring consistency. Thought for 6 seconds, and in 6 seconds saying make sure the brackets are all closed. There's the revised code. It's not very big. That last program was 1,000 lines, and it says it's fixed these issues. Let's see. Here's the program again. So let's do, I'm not sure if that's on, yeah, that seems to be working now. So it's fixed the degree and rate. So now it's working radians. Do sine of pi over 2. Oh, divided by 2. I'm trying to use the keyboard. 1, spot on. Except one thing I'd say is it hasn't actually, although it is closing the brackets, it doesn't show it closing the brackets, so that's not quite so good, but it's never mind. Let's do cos of, let's go to degrees, do cos of 30 degrees, which should be root, what do I mean, yeah, root 3 upon 2, oh, right, cos of 30 degrees, 0.866, that's correct. Divide that by 2. I think it's got it now. On that, is that the third try? I think it's got it right in the third try. Compared with before, it's not good. Let's see if the log works. That's log to the base 10, obviously. So log to the base 10 of 1,000 should be 3. I've got that right as well. Let's do log. Log of 1 should be 0. That's obviously long or log. That's correct. Got that right. I was going to say to get e to the power 2e squared. Didn't like that, did it? No. Oh, I see why. Because it's got a problem there with the with E. I think that was my mistake. I didn't clear the screen properly, so it's got full error handling. At the moment, it hasn't got that. Let's do sine of 30 degrees equals half, which is correct. So I'll just say to it, well, I mean, it's kind of nearly there. I just wanted to tell it to close the brackets or not to put the brackets in. I think it's, oh, I think otherwise it's kind of working, isn't it? We do log of, let's do log of E. That should be 1. That's spot on. It's got most things right. 5 times 6. 30 divided by 5 equals that. Yeah, that's not bad. So I'd say it's near. I mean, for the third go, I think it's pretty damn good. I don't think it's really taxing it in any way whatsoever. I suppose what we could ask it to do is do the bracket thing better. So cos, for example, of 30. It's not going to know when I close. I wonder if it can do a thing within there. I doubt it. So that's doing cos of 60. Bet that doesn't work. My God, it does. Also it can do functions of functions. That's actually quite clever. So maybe, yeah, maybe it can do, yeah, I suppose it's not too hard to do. Sine of 60 degrees over 2, yeah, maybe not. Maybe it's quite, it's not going to know when I finish the expression, of course, until I press equals. What I should tell it to do is to close the brackets when I press equals, even though it's actually working. So I'll get it to do that. This works. So when I, for example, do a sine of pi, you don't close the brackets on the screen. It would look better if when equals is pressed, the brackets are then shown closed. But maybe, of course, it's so fast it wouldn't be able to do this. Let's see what it does anyway, and then the answer. But I mean, it'll do whatever I say. Balancing display, enhancing expression. Balance and evaluate method. Counts the number of opening and closing brackets and appends the necessary closing brackets. Forces the GUI update. It probably will give me things to do, things to improve. Yeah, so it ensures that the display shows a balanced expression before updating the results. And then these are the things it can put in afterwards. Let's try that. This is how quick it is to change things. Do it again. Here's the calculator. So let's do sine of pi again. No, it's still not. Then when I press equals, there, I put the brackets in, and then did a slight delay, and then it fixed it. It did it. Now, I don't think we put brackets in normally in a calculator, do we? I've got another calculator. I don't think it works that way. I mean, again, I didn't tell it. I've got. Where's my calculator? Here's my other calculator I did. Let's just do sine of where's, I don't even, there, pi. Oh, sorry, there's an error straight away. Oh, I see. Yeah, it's the wrong way round. You do pi and then sine, which is close to 0. Normally, the operation comes after the thing that you enter. So if you're working in degrees, so for example, where's degrees here? Degrees, right? So 30 degrees, and then sine that. But this calculator here is the other way around. You don't put the number first. You put the number first and then sine. It comes out like that. Let's put that, and it'll come up with a syntax error presumably, because that's not doing anything. Yeah, because it's there's no multiplication there. So that's interesting. It's reasoning the other way around from a normal calculator. Maybe what I should have done from the outset was to tell it how to do calculations. It's just sort of decided by itself that when you do a trigonometric function, you do the sine and then you put the stuff in afterwards. So I'll change that to pi over 2 equals. But yeah, other than that, it's working. That's the third or the fourth go, I think it is, and there it is.